Hello, today we are going to present the new improvements that we did for CivilFEM for ANSYS 2022. So for these new improvements are the resume of these improvements. The more highlighted ones are the three ones you consider. We have improved the design tools for concrete beams. So now we are able to design any type of shape cross section, not only the predefined ones, which are rectangular, I sections, T sections, and any section that could be defined by the user with any shape could be designed with CivilFEM, and also automatic combinations, basic on codes, and we have updated the ACI318 to the last version. So this is for CivilFEM for ANSYS. We have the CivilFEM products. We have three different CivilFEM products. We are going to explain for you to not to mix between them. The first one is CivilFEM powered by Mark. The solver is Mark from MSC Software from Hexagon, and the graphic interface and all the many tools are from CivilFEM. We are adding a lot of capabilities, tools for solvers, material models. Lot. And
if you have an ANSYS standalone installation for the mechanical PDL, there's an add-on. CivilFEM works as an add-on. Okay, this is the one we are going to explain today.
So so we have a CivilFEM for MSC Software family, also CivilFEM for ANSYS. This mechanical for ANSYS mechanical APDL, which works in the classic environments, and we are adding, we're working like an add-on, adding a lot of capabilities, graphic in the ANSYS mechanical PDL graphic interface. And the last CivilFEM version is CivilFEM for workbench, where we added some ACT extensions, also adding some capabilities and customizing ANSYS for the civil and structural and geotechnical fields.
Okay, CivilFEM for ANSYS, how does it work within ANSYS? Okay, you can see here the menu is integrated after the ANSYS main menu, and the structure is the same. You will have the APDL commands, but including this particular symbol in the beginning. So the workflow is the same, and you will see that today.
So CivilFEM for ANSYS mechanical APDL, which is the version we are seeing today from CivilFEM, is working on classic ANSYS and adding new commands, new capabilities, so you're working like only with ANSYS. And well, here we have some examples that were done with CivilFEM plus ANSYS, covering all the important civil and structural engineering fields, bridges, dams, buildings, tunnels, foundations. And, well, also there's an important capability, well, an important module for nuclear power plants. And here you have some examples of nuclear power plants where you can design following the nuclear codes. And well, coming back to the new improvements that we have for this CivilFEM version, we are just seeing the new CivilFEM for ANSYS mechanical PDL version. Just here we have the three main capabilities we are adding, which is concrete beam design for all type of cross sections, automatic code combinations, and ACI 318 update. So we are going to see an example of a bridge, of this arc bridge. And just with this example, we will see all these capabilities. Well, first, as it is CivilFEM works for all code and standards, we can select the active code. So well, if we go to the software, yes, we go to the software. Well, here you have the bridge model. Here you can see, and well, it is made of beams, so it is a beam model. And the first step is selecting here, you can see the active codes. You have active code for steel, reinforced concrete, pre-stressed concrete, and seismic codes. So well, here you have the long list of codes you can use, and the last one, which is ACI318, that we will use for checking. And of course, as I said, it is for all type of cross-sections. So there are several ways to define the cross-section. As this is a bridge, we are working with the bridge tools. So here in the CivilFEM, tools are divided also in preprocessor, postprocessor, and solution. So in cross-sections, you can define cross-sections using the bridge module tools, bridge sections, and you can define here in the bridge sections, you can define a slab or box type, and then here you can select different shapes, and well, there are some tools to define that. We are using two shapes for this, one which is this box, concrete box section for the deck, and for the arc we are using this other cross section. And well, also, well, these are some tools for bridge design, but also CivilFEM has some tools for cross sections, regular cross sections that you can define concrete. And here you have, you can define from concrete, not cable. And here you have different shapes that you can select and define by dimensions. And also, after defining all this, any type of shape, basic of this, also you can create your own sections using different tools from the software. If we check an example here, a generic section, you can see here we are mixed in ANSYS commands and CivilFEM commands, so it's working all together. If I'm launching this part, I'm generating
to this section.
Yeah, to this section. If I launch it here, so you can see that what I'm doing is creating my own section, which are made of two circles plus a rectangle. I create a mesh with mesh 100 and I capture it. So now I get this cross section, and CivilFEM, this is where the reinforcement will be placed, and CivilFEM can design this section. When capturing this cross section by CivilFEM, the mesh you create with areas, CivilFEM calculate automatically the mechanical properties, and just also considering the reinforcement and the interaction diagram, CivilFEM can design any type of section. But we are going to focus on the bridge, and just to continue seeing those options. So well, these are the cross sections that we are using for this bridge, as you said, and we have predefined a minimum reinforcement amount in all the phases of reinforcements of feet 12, that is 12 millimeters diameter of the rebars, and the spacing is 30 centimeters. So that is the minimum reinforcement amount, and we have placed it around. So what CivilFEM will do is increasing the reinforcement groups that will be needed for fulfill the codes.
Okay, another new improvement is the automatic code combinations. Before, the user had two options, using the combination editor that it's available in CivilFEM, and generate what we call the smart combinations using targets and so on. And the other option was defining the algebraic, let the software create all the algebraic and possible combinations once the user have filled the different coefficients. Okay, in this case, we have in this example, here you have the new tool, the code combination. I will show you. We can add different options. Okay, but here is the window. Yeah, it's very different from the other CivilFEM windows. You can choose between the different codes, and of course more codes will be available. you can add the different, in this case, we had 39 load states, if I recall, right, for different category of type of loading, self-weight, of dead loads, live loads. Okay, so you can include them here, and then you can, depending if they are for ULS or SLS, you can, as you know, the Eurocode has a very particular way of combination. So in this case, the different coefficients must be set by the user. Okay, if they are favorable or unfavorable. For the same for persistent and transitory, accidental. Okay, you will set the different coefficients and the combination factors. Then you can include as well the concomitants of loads, and the most important thing is here where you can generate the preview. Okay, and you can set here and generate the preview of different loads, and you have them here with the and once you calculate them, you will have the full list of combination of loads.
So, well, as you can see, you can select if that is ULS, that is ultimate limit state, and seriality limit state. Then you select the load steps you have solved. You classify them into permanent loads, accidental loads, overloads. Then, depending on the type of loads, CivilFEM will select some coefficients and create this table. With this table are the combinations on left, and on top you have the different load steps you have solved. So this is like an Excel file table where you have the coefficients that are automatically applied to every load step for every combination. So you can, if you would like, you can modify these combinations very easy in this table.
Yes, you can select or unselect all of the possible cases. For example, this one, this P2 combination is the self-weight multiplied by 1, one of the live loads multiplied by 1.5, and the same for the rest. Okay, if you want to include the snow or seismic load, it will be included in all of them. Okay, what happens if we choose the other? I have here another. If we choose the other window, here's the other. If we choose the ASCE, okay, here there's a different type of loads. So once you add all the loads, you have to choose the type. Okay, here I selected the basic ones. Dead. Here you have the combo list. Roof lie, wind, seismic, rain, snow.
So what you are adding, what you are doing here with this window is adding to every load step a different tag to identify these load steps as a load type. So just permanent load, live load, death load. So with this, just once you to classify these load steps into different load types, CivilFEM can create automatically the different combinations based on the active code that we have selected. Previously, we saw the Eurocode. Now we are seeing the ACI 710, and well, depends on the active code. You have different sort of combinations.
Yes, and here the coefficients are automatically inserted. Here you don't, the user does not need to include them, because this code combination tool will include them automatically. Here you can see as well, you can include both of the types of design, the strength and the allowable stress design.
Well, this is in the Eurocode. We define with the Eurocode the SLS and ULS combinations, and in this case there are two different main type of combinations that are strength design and allowable stress design, which are more or less similar to ultimate limit state and seriality limit state from Eurocodes. So,
and very useful as well is the document generation. Okay, you can generate the document of code combinations, so you can check there all the different all the list of combinations. Okay, with the different coefficients. And then important, you have them once you solve them, you will have them in your RST and RCB results file accessible. So and later, as you will see, we can design the reinforcements.
CivilFEM generates some extra load steps into the ANSYS result file, and these new load steps come from the combinations. So you will have the load step that you have solved, the unit load steps, and then with this CivilFEM tool, you create some extra load steps that correspond to this combination. So as you can see, we have different, here we have a menu with different options, but also you have a command that creates this, just to do this. So in this case, for code checking and design, we have both options, checking and design. And it is, you have access through the menu here at the post-processing. You will have here the active code from concrete, and you can check or design. Check for checking, CivilFEM analyze the reinforcement amount you have, and you will analyze the reinforcement amount you have and gives you a safety factor if that is okay or not okay. For design, CivilFEM calculates the reinforcement amount. So we are going to see just we are going to see in the bridge module the load steps we are going to the load step we have to do for a design. So if we open the bridge, so what I'm going to do is just use the this macro and solving just to generate the bridge. You can see the commands, and we are going to create the bridge, solve some load cases, just 2 of them, and design it. So here we generate the bridge with the macro, just generating beams and elements, and here we apply some loads and we are creating just a couple of combinations. Here you can see the bridge, and well, it is a beam model. You can see that if we plot it without shape, this is the beams, and we can plot it with shape, and then we can see just the real shape of these beams. We have different type of cross sections. Here we have the arc, which is, I'm going to remove all symbols. So here you can see that for the arc we have this type of box sections with one diagram. We already see the cross section for the deck, and well, we have 2 different groups of columns. At the beginning, 2 groups to support the lateral loads, and this other smaller one, which are rectangular and circular sections. So well, for this case, we are going to we have created different components, the deck and the arc. So we are going to just select only the arc, and we are going to design this using CivilFEM. So here you can see that we can do with macros, or here with these macros, or with using the browser. So well, the first step in Civil Post Processor, we have solved 2 different load steps, so which are 2 combinations. I'm going to read one of them, and here we can plot in example. We can plot and graph forces and moments. We can plot in example bending moments, set bending moments, and here we have these results. So we are going to use these forces and moments for designing. So first, code checking. In this case, I have Eurocode 1 because that is the active code I have selected at the beginning. It could be ACI or any CivilFEM code. And I have the option of checking or designing. For designing, CivilFEM calculates reinforcement amounts. I can design shells or beams, also solid elements cross-sections. This is an old tool. And here we can perform 2D or 3D axial plus bending design and also shear torsion. This is for the ultimate limit state. So, well, in example, if I perform a 2D axial plus bending, I would like to calculate reinforcement amount, and I can check it in the different planes, XY planes or XZ planes. That is the around bending moment Z or bending moment Y. That is vertical or lateral bending moments. And once I select it, I could press OK, and CivilFEM will design will calculate the reinforcement amount. Also, I have two limits here, like a minimum factor and maximum factor for my design. What is the reason of these values? That is because here you can see in the preprocessor, I have created my cross-section, and I have defined it with a minimum reinforcement amount. In this case, I have simplified the model with only two reinforcement groups, top and bottom, and in both of them, I've created a minimum reinforcement amount of 12 millimeter diameter of the bars and a spacing of 30 millimeters. So I don't want the software to go below this limit. So as I don't want to go the software below this limit, what I have to do when designing here is to say that my limit will be 1. That is that I'm keeping, this is the factor for my reinforcement, so I'm not reducing below that limit. So my limit is 1, this is the factor for that. And my upper limit could be, in example, 32 millimeters diameter bar, which is the maximum bars I would like to use. And then, if in that case, I should place here that maximum limit. Also, I can define several layers of reinforcement in the same face, in top or bottom, define several layers. So when the software reaches this limit, in example, 32, that is the diameter, the maximum diameter of my rebar, start adding rebars in the second layer of that face. So if I leave it in blank, CivilFEM will calculate reinforcement amounts. That is the mechanical reinforcement amount. That is the rebars that are needed for those forces and moments, without considering minimum reinforcement amount or maximum reinforcement amount, considering minimum spacing I can have and the rebars. If I would like to consider them, I add here those values. So well, just once I have those options selected, I press OK, and just the model is it's the CivilFEM design it. Or I also can use the command. In this command, you can see the command is very similar to ANSYS commands. This is dim.com, concrete sections dimension, this is for dimension. 2D design, it could be 3D design also, if I would like to consider, if I have in example, a column with a biaxial bending moment. And well, if I launch this, CivilFEM design this part, and well, also I can plot results here, plot results, also plot the interaction diagram, but well, I also have these commands, plot results from concrete, and I have the two different reinforcement groups, reinforcement group 1 and reinforcement group 2. So I can plot the results. And this is the reinforcement. The reinforcement amount, it is plotted in terms of as my units are square meters or per meter, these are the results in square meters per meter. So the maximum reinforcement amount, this is the top reinforcement amount, this is the negative reinforcement. So in these big supports, it is needed just 172 square centimeters per meter in this points due to the negative bending moment. And here you can see this value, which is 0.039, which is the minimum value that is feet 12 every 30 centimeters. So this is my reinforcement amount for top. And for bottom, these are the bottom bending moment, the bottom reinforcement amount, and also here in these other points in the middle of the span we need up to 93 square centimeters per meter. So this is the design considering the ultimate limit state, the ultimate loads, and this is the reinforcement amount I need. This reinforcement amount could be about, well, less than a diameter of 32 millimeters, which is the other bars. So I can modify my reinforcement groups here and say, okay, now I want to work with, instead of a diameter of 12 millimeters, for those zones I'm going to use a 32 millimeters. Also I can select other standard rebars from Europe. I'm using this one, top, and from bottom I'm modifying them in those zones and place the 32 one that I have seen, just checking the reinforcement amount, that it corresponds to about a 30 millimeter section. So once I have this, now I can verify if these cross sections are okay. So going again to post-processor, instead of designing, what I'm doing is checking now, and I'm going to check these beams to the axial place bending without limits, press OK, and now what I can plot here in results, plot results. In this case, that is the safety factor. If the safety factor is less than 1, it means the section is okay. So clicking on OK, I can see that this safety factor is less than 1. If I plot the interaction diagram of a beam, well, let me check the list of elements. I'm going to plot in example one of these from the 32 element, which is in the middle. So from 32 element beam, okay, 32 M set. So here you can see the interaction diagram. This is the action. This is the axial force bending moment. This is the interaction diagram due to the new reinforcement groups that I have added. The green point are my forces, and the ultimate strength is this point. So that safety factor we give, that is 0.92, is the ratio between the center of the interaction diagram and the ultimate strength. That distance divided by the distance between the center and the green point. So if that ratio is less than 1, it means my forces are inside the interaction diagram. If that ratio is greater than 1, it is outside. The greater, the farther the point is. So also after designing this new tool is designing any type of section. So we are only talking about that. But after this, we could read a new load step, which could correspond to a serviceability limit state, in example combination 2, and then we could perform cracking checking, set by code, and now cracking checking, and this is following Euro code. We have to select the type of loads we are using for certain loads, the type of reinforcement we have, also different coefficients that depends on the national annex. And well, in this, and also select the maximum crack width, the allowable crack width, which is an example 2 millimeters in my case. So I could press OK, and then CivilFEM design this section for cracking. But this is an old tool, and the tools we are explaining is that CivilFEM can design any type of tool. This is for designing the deck, and also CivilFEM could design the arc. So also with CivilFEM, you can perform the construction process of this arc using cables, using different towers here to hold the different parts of the construction the model. And here you can see that this is another model that is solved, and also, of course, we are solving under self-weight and some other overloads, and CivilFEM can design all these construction process steps. For the construction process, you could use the ANSYS tools of birth and death, killing and aliving elements, or you could use CivilFEM tools. CivilFEM tools are using material activation and deactivation values. In example, just for the calendar, you create a calendar time where you place a different concrete on the different parts of the arc. So you create different materials with different activation time. So you create an example, you place concrete the day 0 in the first part of the arc. The next part is the day 21, next, and so on. So you create different concretes with different activation and deactivations. The important part of this activation and deactivation part of CivilFEM is that CivilFEM not only kills or alives the different elements, but also updates mechanical properties considering the different material properties. So as the concrete is a time-dependent material property, so CivilFEM will calculate the age of the concrete and calculate the mechanical properties based on this age. We can perform a construction process and also design all this construction process. Here you can see some plots of bending moments due to this construction process. Also, we created an envelope of the reinforcement amount that are needed during all the construction process, and also once the bridge is constructed, the overload combinations, and we create a final envelope of the reinforcement amounts. So with this tool, you can see we can create, design any type of concrete beam cross-section and be designed with CivilFEM, also considering not only calculating mechanical reinforcement due to the forces we have, but also considering minimum and maximum reinforcement amount the user could define.
And today we just show the beam elements, but of course, in the current version, you can design shell elements as yes, well, and solid elements, but that will be shown in another webinar.
So, well, as a summary, we have 3 different CivilFEM products: CivilFEM powered by Mark for the MSC software family, and also CivilFEM for ANSYS, which that could be for mechanical APDL, which is the one we have seen, and another CivilFEM for workbench that we have some AASHTO extensions. These are the new improvements for CivilFEM for ANSYS mechanical APDL. We will add these tools also for the rest of the CivilFEM, but at the moment they are only available in CivilFEM for ANSYS. This CivilFEM for mechanical PDL, as you saw, this is a customized version of ANSYS, where we add some tools for concrete and steel structures design by most of the international codes, Eurocode, ACI ones, ACI, Russian, Chinese, British. Also, we have some important modules like the pre-stress concrete ones, that we can calculate pre-stress in effect on beam, cells, and solid elements. Also apply equivalent forces to the model, combine this pre-stressing effect, calculate losses, long-term and short-term losses, and also we have a lot of tools for geotechnics, bridges, and nuclear power plants. And well, also, just for giving you a small information about about the company in the cyber, we are specialized a civil and mechanical engineering company. We are the developers of CivilFEMs, but we give full support to our clients. We not only develop and sell them the CivilFEM, also we develop tools under demand. If you need any special tool that any other software doesn't have, we could develop for you. Also, we could help you with the modeling and everything, giving you consultancy, just helping you with the simulation, just basic on FEM simulation. And also, we can give you some finite element analysis trainings on site, or also we need a master and e-learning platform.
Yes. According to this last information, yes, including all the services that CEB provides. We have two ways of sharing our knowledge. One is using the FEM Masters through the Open University, UNED. Okay, this is our 27th edition. Okay. After, well, actually it's on 27th, the 28th, and more than 4,000 engineers. Okay, you can combine here foundations, theoretical foundations, and practice with the software. And the other way, if you want to learn a software, not only for civil engineering, because you have the free FEM course, you can use ANSYS, Pattern, and CivilFEM as other software. Visit this website for further information.